Welcome back, everyone. It is week 2 of required learning. I hope you all survived the first week okay. I got so many responses from all of you. It's really incredible how required learning can kind of just kick things into gear. So I really appreciate the turnout from last week. Um, if you haven't noticed, there's a bit of a change of scenery going on right now. I am no longer in my bedroom slash office because outside, my dad and grandpa decided to just start building a shed. And so there was tons of hammering and sawing sounds going on, which just isn't really best if you're trying to film a lesson. And honestly, those sounds weren't even that bad. The worst part of it was my dad's voice because he's the loudest person on planet Earth. So I had to switch to a different room. So hopefully this sounds a little better. The lighting is maybe nicer. I don't know. We'll find out. But I have to say, in terms of presentation with this lesson, I have cracked the code. After looking back at last video, I realized that it was probably like the ugliest thing ever because, I had like, the toolbar on the top with like all of my websites, and I had the toolbar on the bottom with all of my apps. And it was just very busy. And like, I didn't know where to put my camera at all. So I was constantly just like all willy nilly everywhere, and it was just like super ugly. So this time around, I included little boxes on my slides to indicate, hey, you should put your webcam here because it's not going to interfere with anything, and you're not going to be dragging it around trying to figure out a place while words are popping in everywhere and you don't know where the next free space is going to be. So hopefully this lesson looks a lot less ugly than the last one does, maybe a little more simple. We'll find out how that goes. But yeah, welcome back. We are going to do 8.2, and it is going to be factoring and multiplying polynomials. So the multiplying part, you guys are going to be totally fine with. It's just distributing. We've done it all before, but the factoring is a whole new beast. And I'm going to tell you all right now that this is probably a section I would have spent 2, probably 3 days on if we were still in school. So just take that into consideration. This one's going to be a lot of new stuff. So just try to buckle in and, you know, feel free to ask me any questions afterwards because this might be a tricky one. But we're just going to dive right in and see, look at that. There's my box. I know exactly where to put it, and it works out perfectly. Also, this view is really funny because I can like actively change the size of my window. You can even make it vertical. So it's like, hey guys, I'm making a TikTok. Here's my dance to the Savage remix featuring Beyonce. It's all good. So this one is kind of funny, but I can shape it to a nicer size if it's ever too big. But just to warm up, we're going to work on distributive property because we're going to be doing a lot of that today. So I've got 2 problems right up here. And don't forget, when we distribute stuff, if I've got some number on the outside of parentheses, I'm just going to take that number, which in this case is 2, and I'm going to multiply it by every number on the inside of my parentheses. So really, I'm going to end up doing those little arrows that I would have drawn before. And so we're just going to do 2 times 4x and 2 times 7, just 2 times all the things that are in parentheses. And I left a little plus in between because they already had a plus in between. So I'm just bringing that down. So with my first term, I'm just doing 2 times 4x. We're just going to multiply the numbers because the variable does not get affected in this case. So it's just going to be 8 and x as well. That x just stays. And then I'll keep my plus and then have my second number, 2 times 7 plus 14. That's all it's going to be. This is try one stuff. Not super worried about it, but just a refresher in case you needed one. And then my second one, I've got negative 5 times, in parentheses, 6 plus 3y. So we're going to do the same thing. I'm going to do my little arrows, multiplying negative 5 by both those things. So times the 6 and times the 3y. So first one's not too bad, just regular numbers. Negative 5 times 6. Calculators are our best friends. It should just give me negative 30. And then my second one, I've got to do negative 5 times 3y. So I'm just going to multiply it by the 2 numbers. So it should be negative 15 and keep that y. So you should end up with negative 30, keep your plus, negative 15y. You could also have negative 30 minus 15y. Doesn't matter to me. I'm just trying to keep it consistent. But just know that we're going to be doing kind of similar stuff with distributive property today. So here's a refresher in case you needed that. But on to new stuff. We're going to try distributing, but we're going to do it with polynomials this time. So I'm going to add in a little extra variables, maybe some exponents in there just to kind of just spice it up a little bit, give it some flair. So it's going to be the same thing, same conceit though. So in this case, I've got 7x on the outside of my parentheses. So I'm going to multiply it by x to the third and 4. So obviously your first step would just be like normal, just distribute. So take that 7x, multiply it by the two things on the inside, that x to the third and the 4. And I kept that plus in between them because they've got a plus in the original problem. And here's where things can get kind of funky. So I broke it down step by step. Now, when we're multiplying, we want to multiply our coefficients or our just regular big numbers like normal. And when it comes to variables, we want to add the exponents on them because don't forget, before all this mess happened when we were talking about exponents, if I multiply the same variable, we add their exponents, right? And so looking at this first little set of parentheses, I'm going to do 7 times, there's no number in front of this x. So don't forget, if there is no number in front of a variable, what can we assume it is? I'm sorry, what? Yeah, exactly. It's a 1, right? So there's a little 1 right there. So I'm going to do 7 times 1, which crazy, just 1, or 7. God, can't do math. Also, thank you, Cooper, for catching that mistake I made last week. I hope I didn't catch any this time. We'll see how it goes, but just let me know if something doesn't look right. And then when I multiply my variables, x times x to the third, well, this x right here doesn't have an exponent above it. So if I don't have an exponent listed, what can we assume that exponent is? It's gonna be a crazy one. It's gonna be a real revelation. It's also just 1. So this is x to the 1 power right here. So don't forget, when I multiply my variables, I just add my exponents. So x to the 1 times x to the third, that should just be 1 plus 3 x to the fourth. So your final answer for this little section should just be 7 x to the fourth for that one. And then with this second set of parentheses, I just have one extra rule. If a coefficient doesn't have a variable, so in this case, this 4 is just kind of chilling by itself. There's no other x next to it. Then we're just going to multiply our coefficients like normal. So 7 times 4, which should give us 28. And then since this 7 has an x with it, we're just going to slap that x on. We're just going to bring it over. So this second part should just be 28x. That's it. Those are all the things you need to watch out for. So really the only difference with doing it with polynomials is that you might have some extra variables that you have to work with, and that's where exponent rules come in. So don't forget those. So let's just try a few just to make sure we all know what's going on. My first one, I've got 2b times b plus 11. So same thing with distributing. I got to do 2b times b and 2b times 11. Do those all separately. So with that first one right there, I'm doing 2b times b. Well, there's no number in front of it, so I can assume that's 1 right there. So I'm doing 2 times 1, which gives me 2. And then b times b. Neither one of these variables have an exponent above them, right? So I can assume that's b to the 1 and b to the 1. So really, I'm doing b to the 1 times b to the 1. I'm just doing 1 plus 1 should give me b to the 2. So with this first one, I should have 2b to the second power. And then with my second one, I'm taking 2b times 11. There's no variable on here, so that b is just going to get slapped on. So 2 times 11 gives me 22, and then I'm going to keep my b, and then you'd be all done. My other ones, I did not break it down with that second step because I was like, this slide already has lots of numbers and variables on it. It's going to be a lot. So I just stuck to that next step. So with this next one, I'm doing 3m to the second power times 10. That 10 doesn't have a variable, so we're going to keep that m to the second power. I'm just going to do 3 times 10. So it gives, God, I've already forgotten how to talk. I got my water next to me just in case. So I should have 30, 3 times 10, and I'm going to keep that m to the second right there. And then for my second term, I'm taking 3m to the second times m. Well, again, There's no number in front, so we can assume that's a 1. And there's no exponent, so I can assume that's a 1 as well. So 3 times 1 gives me 3. M to the second times m to the 1. I'm going to add those exponents, so it should be m to the 3. 3m to the 3 as the whole thing. And then looking at the ones I've got down here, I've got w to the second power times w. So no exponent on that one. I can assume it's a 1. So in this case, that first one should just be, oh man, this is going to be a mess. All these like drawing tools right here. You can barely even see it. So I'm going to have w to the 3. And then that second one, I'm just taking a variable times a number, which if you remember the days way back in try 1 when I told you if I'm multiplying a variable and a number, can't do anything, so we slap them together. So I've just got 15 w to the second power. And then my last one, I decided to be a jerk and I gave you 3 of them to do. So I've got 4x times 2x to the 3, and there's no exponent on my 4x to the 1, so we can assume that's a 1 right there. So 4 times 2 should give me 8. X to the 1 times x to the 3, I should get x to the 4th power. Second one, I'm doing 4 times 7, which gives me 28. And then x to the 1 times x to the 2, I should get x to the 3. Don't forget, if I'm multiplying my variables, I have to add their exponents. I'm going to keep reiterating that a bunch of times. And then my last one, I've just got a little x all by itself here, so I can assume that's x to the 1 power. So I'm just going to carry my 4 over because I can assume there's a 1 in front of it. So 4 times 1 gives me 4. X to the 1 times x to the 1 gives me x to the 2. So I might throw in one where you got to do 3, but you're just doing exponent rules. It's nothing crazy new. It's still distributing. Oh wait, I forgot. Didn't it have something where it said wipe the screen? Oh hell yeah. There we go. That is what we love to see. Okay. So that is it in terms of stuff that's, not super new, but now we're going to get into the new stuff, which is factoring. So I broke it down into a bunch of little parts. And so just to kind of make it as easy as possible, I'm going to try and go through each one. This might be kind of long, so maybe you should pause this video, get a snack, get some coffee, get a Monster Energy drink, whatever you need to keep you up and moving on this day, whatever's going to work. So part 1 is going to be about factoring just regular numbers. So I want to ask you, what pairs of numbers multiply into 18? There should be 3 pairs that you should think about. You can pause it and think about it if you want to, but I'm just going to get right into it. Obviously, if I'm thinking of numbers that multiply into things, obviously 1 and whatever that number is always going to be the first one you should think of. Second one, an iconic duo right here, 2 times 9 also gives me 18. And then there should be one extra one in between. It should be 3 times 6 gives me 18. Those are all the different pairs you can use. And you don't have to flip them. You don't have to say 18 times 1 or 9 times 2. It's the same thing. I would just like them like this in one order, and then you're done. So when we come up with all these pairs, and I've got a nice little chart here to show it as well, little stems. When I come up with all these pairs, I end up with the statement saying that 1, 2, 3, 6, 9, and 18 are all factors of 18. They all multiply into 18, and I can all divide them out of 18. And they come with this nice little chart. And speaking of this chart right here, this chart is going to be your best friend right here. I will have this uploaded to Canvas right next to the video. I want you to use this while you're working on assignments because it is going to help you out a lot. It can be hard to think of factors at times. So I've got all the factor pairs from 1 through 100. So it'll show you all the sets for all the numbers. I'm never going to go over 100. It's a bit overkill. We'll see how it goes. Maybe the last week of required learning, who knows? But this I want you to have up at all times to help you out because I'm going to be referencing it a lot. So moving on. So the whole gist with factoring is that we're going to be dividing out the greatest common factor of several terms. And I just threw a lot of words at you with that one. So when I am asking you to find the greatest common factor, I want you to find the biggest number that can divide several terms. So we're going to be using that factor chart to kind of look for all the numbers that a couple factors have in common. And I know I just spewed a bunch of words at you, so let's actually do an example to kind of put it into context. So when I ask you to find the greatest common factor of 8, 12, and 24, I want you to pull up that factor chart and help yourself out a little bit. So I'm asking you, what is the biggest number that can be divided out of all three of these terms? So what can I divide out of 8, 12, and 24 that's the biggest number of all those? So let's pull up our chart. So here's all of our factors of 8. It's just 1 and 8 and 2 and 4. All my factors of 12. 12's got 3 pairs, 1 and 12, 2 and 6, 3 and 4. And then 24 has 4 pairs, all right here. So if I want the greatest common factor, what's the biggest number that's on all three of these charts? Well, if we look at it for a bit, I don't want you to fool yourselves a little bit. Because, 12 is a pretty big number, and I see it shows up on this chart and this chart, but it's not on the 8 chart, so 12's not going to work. Well, damn. Okay. Well, 6 is pretty big. It shows up on this chart and this chart. Ooh, but it's not on this chart either. So you need to make sure that whatever the greatest common factor is, it shows up on all three of them because it's got to be in common. So eventually we should see that it should just be 4 for this one. It's the biggest number that appears on all three charts. So our GCF, or our greatest common factor for all these three, is 4. So that is the first part when we are factoring. We got to find the greatest common factor of a bunch of numbers first. So keep that in your back pocket. We'll come back to that later. Second part is factoring variables. This part is way easier. I don't even know why I made a whole slide for it. It's going to be good though. So when I want you to find the greatest common factor of a group of variables, you just have to pick out the variable with the smallest exponent because it's the one that goes into all of them. So, for example, if I asked you, what is the greatest common factor of x to the third, x to the fourth, and x to the fifth? Well, which one has the smallest exponent? It's x to the third. That's it. So if I asked you that question, just pick out the variable with the smallest exponent and you're done. So that's the second part. Easy. Not too crazy. Part 3, I got to put both of my steps together. So let's review what our two rules are first. If I've got numbers, I want you to find the biggest number that can divide all of the terms. So what factor do they have in common? If you've got variables, I want you to use the variable that's got the smallest exponent. So those are the two rules that you need to remember. Let's put them both into practice with a polynomial. So if I asked you to find the GCF, or the greatest common factor, of this polynomial, 15n to the 4, 5n to the 3, plus 40n, I want you to do those two steps. So let's do step 1 first. Let's find our numbers. So what is the GCF of 15, 5, and 40? Well, this would be a great time to pull up your chart. So there's all of our factors of 15, all my factors of 5, and all my factors of 40, which 40's got a bunch of them. What's nice about this, though, is that since 5 only has 1 and 5 as its available factors, that really kind of narrows it down a little bit, right? Because, again, I'm asking you, what's the biggest number that's on all three charts? It's got to be on all of them. Well, it's 5. Duh. Because this chart only has 1 and 5. 5's bigger, and 5 shows up on all three charts. Not bad. So 5 is the biggest number that can be divided out of 15, 5, and 40. Step 1's done. Now, step 2, we got to do our variables as well. So which variable out of this polynomial has the smallest exponent? Clearly, just by giving it a look, it's n, that very last one, because remember, it doesn't have an exponent, so we can assume that exponent is a 1 right there. So part 3 is just putting those two answers together. If I want to find the GCF for this whole thing, well, my first number was 5, my second one was n, so we're just going to put them together. So the GCF of the whole polynomial is 5n. We just slap them together, as we always have been doing, the number and the variable. That's it. So let's get a little bit of practice with this before we move on to our last step. So I want you to find the GCF of each of these polynomials. And I started off kind of nice. I gave you ones where you only have 2 terms. It's just less to think about. So step 1, find your GCF of the numbers first. So I've got 14 and I've got 35. So let's pull up our chart. So I got all the factors of 14. I got all the factors of 35. It's kind of nice. They only have 2 pairs. That kind of narrows it down a little bit. So I want to know what's the biggest number that's on both the charts. This one's kind of nice because we can clearly see it's 7 right there. They both have a 1, true, but 7 is bigger. So our number GCF is 7. Now let's do our variables. So looking at this polynomial, which variable has the smallest exponent? Well, we can clearly see it's this n to the 2 right here. My 2 options for exponents are 2 and 4. 2 is smaller. So our variable GCF is n to the 2nd power. Last step, I got to put those 2 answers together. So take my 7, take my n to the 2nd power, slap them together. That's it. So if I'm asking you for the GCF, that's what you got to do. Those 2 steps, kind of 3. It's 2.5 steps, kind of. Let's try another one. So I've got 21 n to the 3 plus 18 n to the 2nd power. First step, find our GCF for the numbers. So let's pull up our chart. There are my factors of 21, my factors of 18. So what's the biggest number on both those charts? Well, we can clearly see that it's 3 in this case. You know, 7's a pretty big number, but doesn't appear over here. And 9's a pretty big number, but it doesn't appear over here. So we got to narrow it down to 3. There's our number GCF. And then for my variables, which variable has the smaller exponent? Well, we can clearly see that 2 is smaller than 3. So it's got to be n to the 2nd power again. So got my number GCF, my variable GCF. My final answer should be putting those 2 together. So your final answer should be 3n to the 2nd power. Feeling okay? Last one, let's do one with 3, just to spice it up a little bit. Let's go crazy, go stupid on this one. So I've got 4x to the 3rd plus 12x to the 2nd plus 28x. Numbers first. So I got to find all my factors of 4, all my factors of 12, and all my factors of 28. So again, it's kind of nice when we've got a small number like 4 because that's really going to narrow it down for us. And we can clearly see that the biggest number on all of them is 4. So number GCF is 4, all set. Now, what's my variable with the smallest exponent? That's our second step. Well, looking at all these, I can clearly see that it's x right here because don't forget, if I don't have an exponent written, we can assume it's a 1, and 1 is smaller than 2 and 3. At least in this dimension it is. So if I want to put those answers together, your final answer should be 4x slapped together. So that is finding greatest common factor if you've got a polynomial. And again, it's a lot. Like I definitely would have spent 2 or 3 days on this. So the fact that I'm cramming it all into one video that you have a week to do was a little stressful for me yesterday. I was like, my beautiful students, I just want them to succeed. I want them to understand this okay. Am I going to be talking too much at them? So we're going to see how this works out. So now there's a part 4, but it's not too bad. Now that we found our GCF, in order to do the last step of factoring, I have to divide the GCF out of every term in the polynomial. Then you have officially factored, or it's kind of like distributing in reverse. We'll see what that's like soon. So let's use the same polynomial from our example together. That 15n to the 4 plus 5n to the 3 plus 40n. We already found our GCF for it, which is cool. It's 5n. So if I want to officially factor the polynomial, if I'm asking you to factor something, I want you to take that GCF, that greatest common factor, and divide it out of all 3 terms. So let's see what that looks like. So I'm going to take 15n to the 4 and divide it by 5n. And this is not a new thing either that we've done. We did this in chapter 7. So I want to divide my numbers like normal. So 15 divided by 5 gives me 3. And I want to divide my variables. So n to the 4th divided by n, which has an exponent of 1, And what's my rule if I'm dividing the same variable? I'm sorry, you're really gonna have to speak up. This is not working out. What? Oh yeah, we subtract our exponents, right? So if I'm doing n to the fourth divided by n to the 1, I'm just going to do 4 minus 1. So I should have n to the 3 in that final answer. So you'd want to do the same thing for the other two as well. So I'd want to do 5n to the 3 divided by 5n. Well, 5 divided by 5 gives me 1. N to the 3 divided by n gives me n to the 2. And you can have that 1 in front, but I personally leave it out. So you can have 1 n to the second or just n to the second. And then we'll do our last one, 40n divided by 5n, which is just going to be 40 divided by 5 gives me 8. And then n divided by n, it should give you n to the 0, which is just 1. Anything divided by itself is just 1, right? So you should just have 8 for this one. So with all this mess going on, what does our final answer got to look like? It's got to be all of our new terms. They're all going to be in parentheses. And we're going to have our GCF on the outside of those parentheses. So your final answer should look like this. I'm going to have my GCF on the outside, that 5n, and I'm just going to stuff all 3 of my new terms, like newly divided, into some parentheses right here. And then you are done. So this is why factoring is like distributing in reverse, because if I told you, hey, distribute this, if you did 5n times this, times this, times this, we would get this polynomial as an answer. So we just went backwards. I know, mind blown, right? It's crazy stuff. So this is a lot. Again, I would have spent multiple days on this, and I'm stuffing it all into one video. So let's try a couple more just so we've got context. And I'm going to get a drink first because I'm talking a lot. I can feel that saliva building up. Okay. So let's use the examples that we did before, because having to find a whole new GCF is just going to be a lot of work. So I'm going to use the ones we already did. So going back to 14 n to the second plus 35 n to the fourth, we already found that GCF. It's 7 n to the second power. So if I want you to factor this, you're going to have to divide these two terms by 7 n to the second power. So 14 n to the second divided by 7 n to the second, well, it's just going to be 14 divided by 7, which gives me 2. And then n to the second divided by n to the second, well, it's just one thing divided by itself. It should just be 1, so it's going to go away. You should just have 2. And then my second one, 35 n to the fourth divided by 7 n to the second. I'm going to do 35 divided by 7, which gives me 5. And then n to the fourth divided by n to the 2. Don't forget, we subtract those exponents. So 4 minus 2 gives me n to the 2. So as a final answer, I got to rope all these together, get my new things in parentheses, and then put our GCF on the outside. So your final answer should be 7n to the second, parentheses, 2 plus 5n squared. And I'm putting a plus in there because there was a plus in the original polynomial. That's why it's there. So that would be what I'd want to see. Let's try another one. So our second problem from before, we already found the GCF for 21 n to the 3 plus 18 n to the second. We found the GCF, it's 3 n to the second. So I just want to divide these two terms by our GCF. So 21 divided by 3, I'm going to get 7. And then n to the third divided by n to the second, I'm just subtracting those exponents. So it'll be n to the 1 or just n. You don't have to include the 1. And my second one, I got to do 18 divided by 3, should give me 6. And then n to the second divided by n to the second. It's all just going to go away. It's going to be n to the 0. It's going to be 1. So you'll lose that variable. So if I want to slap all those together, I got to have my GCF on the outside first, and then my new terms in parentheses. So I'll have 3n to the second, 7n plus 6 on the inside. And again, I had plus in between because there was a plus in the original polynomial. So I'm just keeping all the same stuff. And then let's do our last one. Let's do our crazy one. So we already found our GCF. It was 4x for this big polynomial from before. So I want to divide all three terms by 4x. So my first one, 4x to the third divided by 4x. Well, 4 divided by 4 is 1. X to the third divided by x. Don't forget, I'm going to mention it a billion times. If you've got a variable with no exponent, it's got a 1 above it. So I'm doing 3 minus 1, so I should get x to the 2. My second one, I'm doing 12 divided by 4 should give me 3. And then x to the 2 divided by x should just be 2 minus 1. So x to the 1 power, or just x by itself, whatever you want it to be. And my last one, 28 divided by 4 should give me 7. And then x divided by x, just going to go away. Anything divided by itself is always 1. So for a final answer, I'm going to have my GCF on the outside and then all three of my new terms on the inside. And they're all going to have pluses because they had pluses in the original. So there is our final answer. Whew, that was a lot. I just talked a lot. How are you all doing? Doing okay? Surviving? So this is what's going to go on this week. If you have any questions, please let me know. This one might be pretty tricky, but again, like last week for our assignment on Canvas, you're going to be able to take it as many times as you want. So if you're trying to shoot for 100% or 10 out of 10 points or whatever you want, you can do it as many times as you want. Eventually, you're going to end up getting the same questions that you got before, but that's just because I want you to succeed and know what mistakes happened and know how to fix them. So again, any questions, let me know. I miss all of you like crazy. I'm feeling kind of bummed because I'm losing my seniors and I'm like, am I not going to get to have a graduation ceremony for my seniors? Like, I need a good cry right now. So luckily I've got all of you, and I'm going to hope that your graduation doesn't get canceled. Hopefully this is all done in 3 years or whatever. So I'm looking forward to that. But yeah, I just miss seeing all your faces. I really appreciate all of your answers on the check-in questions. They were all just super sweet and cool, and I had a really big turnout again because of required learning. So that was awesome. I just love getting little insights into your lives, and so I can't wait to do that again this week. So make sure to like and subscribe, hit that bell, and let me know if I should start a TikTok account and just do vertical videos like this all the time. Do some challenges. I don't know. Do the Say So thing, whatever. That Say So remix. Yikes. Not good compared to the Savage remix, let me tell you. Okay. Anyways, I hope you all have a great week. Survive this required learning okay. And let me know if you got questions. Bye bye.